Hello everyone. Now I'm going to talk a little bit about the solution of the lab of last week. We are still working with relational algebra, and we are also trying to see the performance of different queries, and we are also trying to improve the performance of the queries. For this reason, we have to build the query tree plan in order to compare the performance of different queries, and also in order to improve the performance of the queries, or to try to improve the performance of the queries. Okay, basically for the first part of the lab, the idea is that we have a database, or the structure of a database, and then we have to write different queries using relational algebra. The first query indicates that we have to get the names of the books, of all the books in the database. Basically what we have to do is to look into the table book, and we want to get the name. For this reason we use the projection operator. I assume that you are quite familiar with all the operators that we have in relational algebra. If you are not familiar with the operators, I strongly recommend that you have a look at the material of the previous weeks. Okay. Basically, this is the solution for this question. The second question, in this question we want to get the ID of the authors born after some given year. Basically now what we have to look, remember something important, I've been saying this a number of times. Look at the question, carefully read the questions, and then focus only in the relations that you need. Okay. If I want, I can just join all the relations in order to get a piece of information. But for example, in this case, all we want to get is information related to the author. We don't need to combine this with books or something else. All we need is to check the relation author. We have everything here. So basically what we are going to look is at this attribute must be greater than this value. Okay, because well, that's the question. Something important that I have to mention, remember that the question is clear. We are asking for the IDs. If we just leave this portion of the query, we will be getting everything, all the attributes from author. And we want to get only the IDs. That's something important. We want to use the projection in order to get the IDs of the authors. So don't forget to complete the queries if you like, because the question is clear, the IDs. This is a very popular mistake that I've seen my students in previous years, that they are missing this particular information, this particular operation. The next question we want to get is the IDs of the authors that live in a particular city. There are multiple ways of writing this query, as with many other queries. And the idea here, we will be combining the city and the author. Basically, we have to combine the city, the author, and the city. And we will be joining this living city ID with, this is basically the ID of the city for a given author. That's what we have to look. So that's why we are using the conditional join. If in this particular case, you have to be really careful and not to be confused with the natural join, because the natural join will be using the ID of the city and the ID of the authors. That's not really what we need in order to combine the two tables. So that's why if you write only the natural join, that would be a mistake, a very important mistake, because the meaning of the IDs are not the same. But if you use the natural join, you will be saying that they mean the same. So we have to indicate the condition. We want to say that the city ID and the ID, living city ID of the author. So that's a particular, very important, relevant detail of this question. If you want, you can also use the cross product as well. And then after this, we will get at least in this solution that I have here, we have the name of the city, we apply the selection with the condition, and then all we want to get, remember that we want to get the ID of the authors, only the ID. So that's why we get the author ID. Something also important, I use author.id because we have multiple tables with ID. So if I use only ID, there is no way in order to know which one. So we have to indicate that is the author ID. This is not the best, the best solution, the most efficient solution. There are ways in order to improve this, but I let you have a look at this and try to improve this. All you have to do is to move this down in the query tree. And that was the first question. In the second question, what we have is a SQL expression, a SQL query, and we want to see the query tree. My advice in this particular case is that you write the relational algebra query and then you translate that into the query tree. Sometimes we call this the logical plan. Basically what we have here is we have what at the end what we want to get, the store. So that's why we have the projection and we want the store. This is the structure of the database. Let me just quickly move this. This is the structure of the database. We want to get the store. And then we want to combine, basically this is what we have here, these two tables, purchase and customer. That's what we want to use in order to combine these two tables. So if we want to combine different tables, what we want to use is, for example, we can use the natural join, we can use the conditional join, or we can use the cross product, for example. In this particular case, we went for the natural join because we have the same attribute name, so we can combine these two. Okay, the customer ID is the same for both, so we don't really need to indicate that because this is the natural join. And then we add the additional constraint. Basically, this is going to be the relational algebra expression. If you want, you can move this portion outside of after the natural join, but that's not going to be the best option. This solution is a little bit better. Okay, remember that this is what we get. We get the SQL expression and then we want to translate that. So basically what SQL is going to be doing inside is trying to optimize this in order to get something like this query plan. And yep, this is basically the solution. And once you have the relational algebra expression, building the tree, remember that you will be building the tree bottom up. And typically we try to push the selections to the bottom of the tree, if that's possible. So basically this is this particular question. And then we get, this one is a little bit more difficult. It's not really that difficult, but we have to try to think a little bit about the solution because we have a lot of things. Now we get the query tree and we want to get a SQL query that represents this particular tree. Basically, my advice here is that you start looking at the attributes that you want to get at the very end. In this case, we want to get F and G. We know that F is coming from R. Okay. And we know that G is coming from T. Okay, so we know that that's this portion that we have here. So basically, this is going to be the output. And we know that we have these three tables, these three relations. So we know that we have to select the attributes that we want to get and the tables that we are looking for. So basically this is the first portion. Okay, we still have a lot of things. You don't have to grade everything in the same order. At the end, what we want to get is in the same order that is appearing in the query tree plan. We want to get an equivalent expression. We don't want to get exactly the same sequence of steps, if you like. Basically now we know, okay, we know that we have these three tables, so we have to combine the three tables, and we also have to filter, to use the selection operator in order to remove some elements. Basically what we are going to be doing at the very beginning, we're going to be writing the first expression, which is just this condition, which is the one that we have here. This is going to constrain the number of elements in this table, and then we write the second condition, which is this one that we have here. Now we don't really need to write this, because remember there are multiple ways of doing that. This is just one query tree plan. Okay, we want to get an expression, a sequence expression that is equivalent, that at the end, if we have the input, the output is going to be the same. That's what we want to get. We don't have to write this. We don't need to get this. We don't have to write a select, for example, for these particular portions of the tree. That's not really needed. You could, if you want, you could get something quite similar, but it's not ideal. Okay, this solution is going to be enough. Okay, so basically these are the two conditions that we have. We wrote the two conditions here, and then these are the two joins. Okay, one is this one that we have here, which is representing this join that we have there, and this one is the second join. Okay, and basically this is going to be the solution for this particular question. Okay, nothing really that difficult. It's not really that difficult. We need to make sure that the output is, for the same input, we get the same output when we want to write these queries. And that's basically all for this solution of this lab. Thank you very much.